Hello and welcome to this session. My name is Peter Senft and I'm a Principal Software Engineer in Bentley Systems' iTwin platform group. The title of this session is Synchronization API, Connectors to the Rescue. So let's dive into it. In this session we will learn about the Synchronization API, why it exists, what is it doing, and its connection to connectors. Next we will review some use cases of the API, and I will follow this up by a demo where we will focus on the manifest workflow. At the end, I will give you some resources where you can find more information about the Synchronization API and all the other APIs that iTwin platform has to offer. Let's start with a general overview. So the Synchronization API, what's it doing? In short, it enables you to synchronize a wide array of different types of engineering data in different file formats into an iModel. The API offers you the ability to set up a connection between your design files and the iModel. When you run such a connection, then the design data is picked up and the connector comes to the rescue. How is it rescuing you? Well, it does the heavy lifting of synchronizing, aggregating, and aligning your data into the iModel. More about that in a minute. So let's talk about the history a little bit. Connectors in synchronization exist already for a while, and they're essential for any powered by iTwin solution that deals with the problem of creating an iTwin. Your engineering data will come from different disciplines and is stored most likely in different formats, and you need all this data in the iModel in order to start any workflow. Connectors are bringing the data in and aligning it. And then the Synchronization API provides a way to control this process within a cloud environment. Well, and now this functionality is actually available for everyone. Let's do a quick look at the goals of the Synchronization API and iTwin connectors. Well, the first goal, mentioned already, aggregating and aligning and synchronizing your engineering data. And the second goal is to detect change and update your iModel accordingly. Now that we have a general overview, let's take a closer look at connectors and their potential to rescue you. Why do we need them in the first place? Our goals are to synchronize, aggregate, and align data. We want to track change. And engineering data and other data comes in many different formats, and we want to support as many as possible. We have currently connectors for more than 40 formats, including our own, third-party formats, and interchange formats. But what does it mean to synchronize? I guess that part is easy. We want to have, after the synchronization, the same data in the iModel that can be found in the source file. Aggregation also sounds pretty easy. All we want is to have data from different domains and sources aggregated so we have it available as one digital twin. So for instance, we want to aggregate data from architects, road designers, bridge designers, electrical engineers, and so on into one cohesive model. And in order to do that, we need to align the data. Without aligning the data, we just have a bunch of disparate objects, lines, and stuff like that. That doesn't really mean anything. So the data gets at least aligned with our BIS schema that defines objects that have meaning, generic meaning in the digital twin. And then domain-specific connectors can align the data using a domain schema, for instance, for building, for road, for rail, and so on. That way, the data keeps its meaning within the domain. A road alignment stays a road alignment, and it's not just a fancy 3D line with some weird data attached to it that nobody understands or knows the context of. Then we want to track change. When a source file changes, we want to see that change in the iModel. And we want to see it as a change and not just, hey, there's a new version without any context. So data is not updated by uploading all the data again and again each time something changes in the source data, but by identifying these changes and using just these to create what we call a change set, which is then uploaded and applied to the iModel. That way we get a history of change and can see where and when decisions are made. This might be important for audit purposes, or it helps you verifying or improving your processes. Now let's have an overview of the Synchronization API. Its main goal is to provide an easy-to-use API that runs connectors. It gives you everything you need to achieve your goal, to get started and create the data in your iTwin. It runs the connectors in a cloud environment, so no need to have your own machine occupied with a synchronization job with an hope that your machine has enough memory or the internet connection is good enough to get this done within a reasonable amount of time. We will make sure that bandwidth is there, the machines are properly sized, and so on. We want to get this job done for you. So for that, we offer two workflows. They're basically defined by where the source data is stored. First, we have what we call a storage connection. This workflow uses our iTwin storage service. A link to the documentation for that service is at the bottom of the slide. In essence, in this case, you would upload your data into the storage service, and it will be ingested by the connectors from there. But not everybody wants to use or can use an external storage solution, so we look for alternatives. Well, we found that most storage services offer a way to create pre-authenticated URLs, and we created the manifest connection workflow. In this workflow, your data can stay within your current system, and all you have to do is provide a manifest with pre-authenticated URLs to each source file that the connector needs to ingest. This is the workflow that I will show you in a minute. And now let's quickly talk about use cases. There are mainly two. First, you're in a situation where you have to integrate a way to synchronize source data into your application. The API offers you an easy way to do so. And the other use case is if you need to have full control over the synchronization process. You know when files change, when source files change and how they change, and you can trigger connections accordingly, monitor them, and make everything work the way you want and need it within your constraints. And now, without further ado, let's try the Synchronization API and let me show you how to create and use manifest connections. All right, let me switch to my browser for the demonstration, and we're going to developer.bentley.com, which is our developer portal, which is an easy way to show the API and test the API. But first, before we can do anything, we need to sign in. That's done now, and under documentation, you can find the Synchronization API. Here you can first get an overview of what the Synchronization API is, and also some nomenclature is explained. Next, let's take a quick look at the supported formats. I mentioned before we are supporting 40+ formats, and we give an overview of Bentley applications, third-party applications, and a bunch of interchange formats that are all supported. It gives you a name or extension in this case sometimes, what type of, what version is supported, which connector supports that file type, and very important down the road for creating the connection, what the identifier for this connector is in the manifest. You can also find tutorials and samples that showcase the API and helps you understand how the API works. But the interesting piece now is the reference where we can use the API. We're ignoring the last two entries for storage connections. They were explained in another webinar, and we're focusing this time on the manifest connections. But first things first, authorization. In order to run a connector job, the connector needs to be authorized to access iModel Hub to upload the change sets. The problem is with a normal user token or any token that you come in, it's time limited, and usually that limit is around an hour. And some connector runs, especially when you have more complex files or complex file sets, they can run, in worst case, multiple hours. Most runs are they're done within minutes, but yeah, sometimes they run longer, and for these purposes we need to capture a refresh token, and this is what this endpoint is there for. Let's try it out. Every endpoint has a try it out button, and first thing, we should authenticate. We can use an authorization code. This is where it comes handy that we are currently authorized against the developer portal. We just pull a token. You can see the authorization is pulled in. This endpoint can be incorporated into your workflow to create your own authentication workflow, and for that we require a redirect URL. I just put something dummy in here, and then I can simply execute this endpoint, this request. We got a 200 OK back and a JSON body which tells us my user is already authorized. In other words, we have for my user a refresh token captured in our database. If we are not authorized, this would be false, and in addition, we would get a URL that you can go to, and that would start the process of capturing your refresh token. So we're good to go here. I can create connections and I can run connections. My connections shouldn't fail because of missing authorization. Let's go to the next endpoint, connections. This is an endpoint that gets you, in general, a list of connections for an iModel, and it gives you a list of all connections, manifest connections, and storage connections. Let's try it out, and I created already an iModel. Let me grab the iModel ID. Let's get authenticated and execute this request. As you can see, it's a GET request, some additional headers. Let's execute it. And as a response, we get currently no connection. There are also some pagination links here. The moment only self, but there could be a previous and next. Let's close this. And let's get started with creating a manifest connection. To create a connection, we need to make a post call to the manifest connections endpoint. So let's try it out and see what we need. First of all, we need to be authorized, and then we need to have a JSON body. I prepared already a JSON body here for 6 files. My iModel ID is here. This is a free-form text field where you can use any name. In my case, I called it civil. The next interesting thing is the authentication type. We have 2 types to authenticate against iModel Hub. One is the user authentication, and the other one is called system. User authentication means that the stored refresh token is utilized to create access tokens for iModel Hub. And in the system case, you have to create your own OIDC applications within the portal, and this is thought for applications that don't have their own user interface, so background jobs and so on. So there's no normal user interaction. Those types of jobs can use a system authentication. But in our case, I have a user, I have a UI, I want to use the user authentication. And then the next is a list of source files that are used. These source files are part of this connection. It can be reference files, master files, or any other type of file that is necessary to run this connection. And they get, in my case, a human-readable identifier. You can also use GUIDs. Nothing stops you from doing that. It's just easier for testing purposes to have something human-readable here. So we're using this file, or this data, to create our connection. Copy paste it in here. We get our request and execute it. And as a response, we get a 201 created and an additional JSON body that gives us more information about this connection. Now we have a new connection for a specific iModel, a specific project. We want to do user authentication, and we have links to the iModel, the project, and also to a last run, which is currently null because this connection never actually ran. We just created it. And at the bottom, we see the display name. There are 2 endpoints to also look if we have connections. First is the get manifest connections endpoint, which gives you a list of connections for a specific iModel. Let's try that here. We have our iModel ID, and we should see our iModel list. Oops, I forgot to authenticate. Let's authorization, execute, and here's our connection. And I also forgot to grab this connection ID, which we will need for further investigations. We can also get more information about the connection itself with this endpoint. That's why we need the connection ID. authorize and execute. And this gives us basically the same information that we got after creating the connection. But I just saw something. I named this connection civil, which is not actually what I wanted. This is actually my microstation connection. So let's change that name. Changing that name can be done in update manifest connection. Let's not forget to authorize. We want to update this connection, and we want to change the name to microstation. We want to stay with user authentication, and we can execute. Ta-da! Our connection is now called microstation. That's a little bit better. Now that we have a connection, let's run it. This can be done with a post to the runs endpoint within the manifest connections. And this is where now finally the manifest come into play. Let me pull mine up. This is the manifest for this run. It basically defines the source files and links the IDs that were defined when we created the connection to a specific file. We define the name of the file when it's downloaded. We define an action. The action can be either bridge or unmap. Bridge means we're synchronizing the data of the file into the iModel, and unmap means we are removing all that data from the iModel. Next, we have the URL where the connector can find the file. This is a pre-authenticated URL as mentioned before. And then we define the connector type. In this case, we want to use the microstation connector, and the connector type is then MSTM. Civil would be for civil, OBD for Open Building Designer, and so on and so forth. In addition, you could define reference files that belong to this specific file, and they would be defined in these children lists. I don't have a reference file at the moment. I just have our 6 files defined here. If you go down here, you can see them. They're all running with the microstation connector, and you can use this file now. Let me copy this and use it in our tryout. In the sample, you can see a child defined. The only additional thing, these are basically normal files, but the only additional thing is the parent ID where we link up to the master file. All right, we copied this over. Need to authenticate again. And we need to define which connection we want to run this on. I copy that here. Oops, that's the manifest. That's not what I wanted. Let's use a real connection ID and execute. All right. This request was accepted. That means we have a new run now. So let's take a look at the status of the run. And I forgot to copy a run ID. So let's check the runs for our connection. We can do this at the runs endpoint. We still have our connection ID copied. And let's see what we have. All right. We have for this connection currently one run. It is in the state waiting to execute, and the result is currently undetermined. Let me copy this run ID because we can get a little bit more information for this run. With the run endpoint, whereas currently we just saw the overall status of the job, but we can get more specific information by taking a look into here. We need to have the run ID and the connection ID. Executed. And now we see for all the files, the status, everything is currently waiting to execute. So let's check in between and see if we get an intermediate status from time to time. Let's fast forward a little bit and execute it again, and we see we're still undetermined, except for the first file is now executing. Fast forward even more. Let's execute again, and we can see our first file is completed successfully, and we're waiting for the next file to be executed. Fast forward even more. We should be now done. Yep, the job is successfully done, but it's still in a finalizing state, so there's some final cleanup that's done by the orchestrator, but that should be finished soon. Let's double check. Yes, now the job is completed successfully, and we should see now some data in our iModel. Let's jump quickly to the iModel and see if we have changes. Currently, from last time opening, there were of course no changes. Let's see, view all changes, and here are all my files, commercial, single platform, and so on. But as you remember, I first called the connection civil, and that is because these aren't just plain DGM files. I created a second iModel and used a civil connector for that. As you can see here, we have 48 change sets uploaded using the MicroStation connector. Using the civil connector, we have 54 change sets. So the civil connector brought in way more data, and I can actually showcase this by using design review. So this is the MicroStation file that was brought in. You can see this line here in the middle of a driveway. The triangles are a little bit odd at the moment, but that's just a viewing issue. And this line is currently just a complex chain, no real meaning behind it. But using the civil connector, it is actually an alignment, a linear alignment. The length is here. It's part of a road network. It has a start station. Some annotation is here. So the fidelity of the civil connector is way higher than the fidelity of the MicroStation connector when you synchronize this type of file. In other words, you should always check the list of supported file types and use the connector that matches your source files to get the best fidelity. So for instance, don't use a DWG connector for civil 3D files or convert files to another format just because you think it's better. You will lose fidelity. Like in this case, I lost fidelity by using the MicroStation connector over the civil connector on a obvious civil file. Let's jump back to the developer portal for a moment. We so far looked only at the manifest connections endpoints. So we saw how we can create a connection, how we can run a connection, how we can monitor it, and so on. But there are other endpoints to manage the source files of a connection. We have the manifest connection source files endpoint, and they have multiple ways of calling them. A post would add additional files to a connection, like for instance new master files, or we have new references that need to be added. We can get all the source files that belong to a connection, or we get additional information about a source file. We can also remove files, source files from a connection. And the last one is to update this human readable source file ID field that we used in the beginning to create the connection, just in case it changed for some reason or we are not happy with the naming. This concludes the demo. So what did we learn in this session? Well, I showed you how to get started and how you can have your engineering data in an iModel. I gave you an overview of what a connector is and how it is utilized by the Synchronization API. And of course, I showed you how to use the manifest workflow of the Synchronization API. If you want to learn more about the Synchronization API and about iTwin platform in general, then please take a look at these links on this slide. I also added the link to the list of supported file formats and of course a link to the iTwin community support page. If you want to start building your own application using iTwin platform, then you can register your free developer account in the iTwin platform portal with the link on this slide. And that's it. Thank you for joining my session. Take care.